Hello, my little mathematicians. Today we are going to review adding and subtracting mixed numbers. Remember always to fully reduce, and if it's improper, to change it to a mixed number. And if you need to, always double check when subtracting if you need to first borrow. With that being said, you can always pause the video at any point in time, try it yourself, and then unpause it to double check if you got it right. Let's go ahead and practice the first one. For the first one, I want to try and see what's the common denominator between 3 and 12. What can they both become? So look at the bigger one, 12. Can 3 become 12? It sure can. So I know that 12 is the smallest number that both 3 and 12 can multiply to become. Now that I have that, I'm going to try to create an equivalent fraction to each one over here. So 12 times what was 12? 1. So 7 times 1 is 7. 7 twelfths is equivalent to 7 twelfths. It's actually equal to it, exactly. 3 times what is 12? 4. So do the same thing on top. 2 times 4 is 8. 8 twelfths is equivalent to 2/3 because it would reduce to that. But now I have 8 and 7 as my two numerators and a common denominator of 12. So I keep the denominator the same, and then I add my two numerators. 8 and 7 make 15. You can see that I circled them. Sometimes I do that just so that I don't get mixed up with all the numbers over here. Don't forget to add your whole numbers in front. 6 plus 8 is 14. And then always double check, can I reduce my fraction or is it improper? This one is improper because the top is bigger than the bottom. So to change that, I take the top and I divide it by the bottom. Top dog goes in the house, or in and out, in and out. That's what a hamburger is all about. Inside the house, outside the house. Okay, that's why I sang that silly song. This one goes inside the house, that one goes outside the house. 12 goes into 15 once. When you multiply that, you get 12. Subtract it, you get 3. Then you put your remainder, 3, over whatever it was you divided by. In this case, 12. And here's the trap. People put the answer is 1 and 3/12. Well, not only is the 3/12 not reduced, but think of that in your head. 6 and 2/3 plus 8 and 7/12 equal 1 and what? How in the world does 6 and something plus 8 and something equal 1 and something? It can't. Don't forget that whole number of 14. This 1 and 3/12 is only representing the 15/12. So you need to add the whole number of 14 and 1, so you get 15, and then the 3/12. Again, as I said earlier, that could reduce by 3, and 3 divided by 3 is 1. 12 divided by 3 is 4, and there's my whole number in front. Now that makes more sense. 6 and something plus 8 and something. Well, 6 and 8 make 14 plus some more. You get 15 and something. Let's take a look at our next one. Okay, I look at the bigger one of 10. Can 6 become 10? No. 10 times 2 is 20. Can 6 become 20? No. So 10 times 3 is 30. Can 6 become 30? Yes. Both 6 and 10 can become 30. Now, if you can't do that in your head, you could always do the ladder method and find the LCM. What's the LCM of 6 and 10? Because that's what a common denominator is. Well, what can go into them both? 2. 2 goes into 6 how many times? 3. 2 times 3 is 6. 2 goes into 10 how many times? 5, because 2 times 5 is 10. Can I keep going? Can anything go into 3 and 5? No. Well then, do an L along the outside for LCM. Multiply 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So that's another way that you can find your common denominator if you can't do it in your head like we did. Now that you have common denominators, let's write these equivalent fractions. 10 times what is 30? 3. So 9 times 3 is 27. 6 times what is 30? 5. So 1 times 5 is 5. Now you have equivalent fractions to your originals, but with the same denominator, so that I can keep the denominator the same and just add these two numerators. Well, 5 and 7 make 12, carry the 1. 1 and 2 make 3. So you have 32 over 30, and your whole numbers, 9 and 4 make 13. 1 and 1 make 2. So you have 23 and 32 over 30. Just like we did last time, I'm going to change that improper fraction to a mixed number by taking the top and divided by the bottom. 30 goes into 32 once. When you subtract that, you get 2. So you have 2/30. And you can reduce that by 2. Always show what you're reducing by so you're less likely to make errors. 2 divided by 2 is 1. 30 divided by 2 is 15. So that means that 32 over 30 is 1 and 1/15. So that I don't forget about this 23, a lot of times I write 23 plus, and then I do this part so that when I combine this down here, I don't forget about the 23. Now 23 plus 1 is 24 and 1/15. Again, remember, you're always welcome to try these first on your own. Press pause, try them, and then unpause the video and double check yourself. What can 2 and 10 both become? Look at the bigger number, 10. Can 2 become 10? It sure can. Or the latter method. What can go into both? 2. 2 times what is 2? 1. 2 times what is 10? 5. Can I keep going? No. Do your L for LCM. 2 times 1 times 5. 2 times 1 is 2. 2 times 5 is 10. So you could have gotten a common denominator that way as well. Now that you have your common denominator, to create the equivalent fraction, what did you do to 2 to get that 10? You did times 5. So do the same thing on top. 1 times 5 is 5. What did you do to the 10 to get 10? You multiplied by 1, which means you'd multiply this by 1, and 3 times 1 is 3. Now this time, we're not adding like we were up above. Always double check that sign. You're subtracting. So you're taking 5 away from 3. Uh-oh. Can we do that? We can't. So I need to borrow from the whole number. Now when you add 1, you're adding 1 as a fraction. Did you know that any number over itself is 1? So if I'm going to add a fraction to this, and it can be any number over itself, why not pick one that has this same denominator of 10? So now I can combine these. The 10 stays a 10, and I add the numerators of 3 and 10, and you get 13. Now I have a big enough numerator to take 5 away from. So 13 minus 5, and that was wonderful cats. 13 minus 5 is 8. And then you keep your denominator the same. Okay. Subtract your whole numbers in front. 5 minus 2 is 3. Can I reduce this fraction? Yes, you can. I'm going to divide them both by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. I can't reduce it anymore, so I'm done. For my final one, look at both 3 and 5. What can they both become? 15. What did you do to the 5 to get that 15? You multiplied by 3. 3 times 3 is 9. What did you do to the 3 to get the 15? You multiplied by 5. Do the same thing on top. 1 times 5 is 5. Can you take 9 away from 5? No. So I'm going to borrow 1 from the 14 and add 1 back as a fraction with the same number over itself. Pick whatever this original denominator was, so that then you can keep the denominator the same and combine these two. 5 plus 15 is 20. Now I have a big enough numerator to take 9 away from. 20 minus 9 is 11. Keep the denominator of 15 the same. Your whole numbers in front, 13 minus 4 is 9. Can I reduce this? No. You're done. Now, what is wise is before you, if this were a test, you write these in the answer column, kind of double check. 6 and something plus 8 and something is 14 and something. So it should be bigger than 14. Yes. Because you don't know how many times I see 1 and 3/12 or 1 and 1/4 in the answer column and not 15. Because we forget about these. 14 and 4 is 23, so it should be more than 23. Yes. Okay, I can confidently write that in the answer column. And then you're like, 6 minus 2 is 4-ish. So it should be 4-ish. Yes, this makes sense. Now, a lot of times they mix it up with adding and subtracting. And so you can get in the adding mode, and then all of a sudden you add 6 and 2 and you get 8, and weirdness happens. So always take the chance that you may have made a mistake. So before you turn your quiz or test in, double check. Just look back over. 6 minus 2 is 4-ish. Double check your answers to see if they make sense. Okay? And then just like this one, 14 minus 4 is 10-ish. Yeah, this is about 10-ish. So I know I'm good. Estimate your answers to see if they make sense. Once you see that they do make sense, and you double checked that you changed all impropers to mixed numbers, and you fully reduced everything, you can confidently turn that quiz in and know that you're going to do very well. Congratulations, my little mathematicians. You just conquered adding and subtracting mixed numbers.